All right, could you like share, give an insight into like what you learned um, during the class, and anybody else on the call could also like share that. There's a reason why I'm asking. So please, if you're on the call, kindly like unmute your mic and talk. You can go ahead, Elizabeth. Oh,
Okay, so the last uh lecturer, she taught us how we could sample, deploy, and compile using Redmix with the demo smart contract that is available on Redmix. How we can store a particular number and then call that function using Redmix. And then after we deployed a sample smart contract after collecting our MetaMask, we were able to view the transaction on the Etherscan. So from there, the other tools she said we would need was Ethereum Remix, Hard. So we did throughout the almost like the whole class was the installation of the Hard, and we were able to install the NPN for the ADAT and how we could start using the VS Code, using the terminal for the VS Code, and also the other tool, which is Solidity extension on VS Code. And also we also did the installation of the error that detects error in case there is a mistake on in our code. And that was what we saw. So we couldn't even finish the installation, and she said she was going to drop material. So that was all we did. But we haven't started coding on Solidity with VS Code.
all right, awesome. Thanks for the feedback. I appreciate. So does anybody want to like add to what Elizabeth talked about? Sorry, anybody? Please, this is I don't know, just a rule of thumb, right? This is supposed to be an interactive class, so whenever like questions is being asked, please let's try and engage. You understand? It's not just like, okay, I'm just here to like teach and then I get off. No, it's supposed to like be interactive. Ask questions. Please try as much as possible to be free. So for everybody on the call, Elizabeth has shared what she learned and what she was able to like pick understand from the previous class. So kindly unmute your mic and talk about your experience in the last class before we proceed to this class. Victoria, are you on the call?
Yes.
Okay. Please go ahead. Were you in the last class?
Yes, I think so. Um,
You didn't say, oh, you know
I
so.
went through the recordings, like I wasn't there live. I'm always busy in the evening, so I always go through the recordings later. And I think the
All
last
right.
class was the one where she was teaching how to set up ADAT and Remix, right? I think so.
Okay.
So yes, I when I went through it later, actually I joined the call, but then I left about like 15 minutes or so. I didn't understand what she was doing then, like couldn't grab it. But then later when I saw the recordings, everything was just smooth. Like I understood it clearly.
All right. So enough of the questions. Nobody wants to talk, Sha, but Elizabeth and Victoria, I appreciate your response. So I just want to like give us a little insight to the ecosystem and the environment, right? I think all of us are familiar with development, like programming, right? We all have had like experience with either building with JavaScript or any. Do we have programming background?
Yes, I do.
If you have programming
My
background, please respond with a yes or just unmute the mic and talk.
I do, but
And
my JS is very
and
basic.
response with the language you're familiar with, like you work with.
Yes, I
My
do.
JS
I'm
is very
familiar with
basic.
JavaScript.
Okay, JavaScript. Which other programming language are we familiar with?
React for me and Django.
React is a library. Django. Okay, Django. Is Django a library or framework?
Framework of Python
Is a
actually.
framework. Yeah. So why I am asking is there are a lot. It's still the same concept, right? But then there are a lot of differences when you're building in Web3. Why did I say differences? I don't know if you've like heard about the concept of smart contract acts, right? Have we heard anything like that?
Dapps,
No, I
you mean
don't.
that, Abby?
Okay, don't let me take us too far. So what I'm trying to say in essence is we are all familiar with JavaScript, and then when you're dealing with JavaScript, JavaScript is basically a tool for like writing web apps, right? It's easier to like utilize JavaScript for web apps. It's not as if you can't use other programming language to do that. But in from my own opinion, I'll consider JavaScript as a garbage language. Why do I say that? You don't need to like manage memory yourself, right? You don't need to like a lot of things have been abstracted out of the box for you in JavaScript. But coming down to Solidity, you have to like keep into considerations a lot of things, right? You know, in JavaScript, you have the concept of primitive data types and I think non-primitive data types, right? Where primitive data types, where you have your booleans and the likes, and then the non-primitive where you have your objects and arrays and things. And there are rules of thumbs to like using those concepts, right? Similar to um um Solidity you're writing, there are rules. Sorry, there are it's a different environment, you understand. So you have to have some sort of mindset, right? Not the regular mindset you're bringing from either developing in JavaScript. It's a different ecosystem here because you are dealing with money, right? Like similar to Web2 apps you're building, yeah, you're dealing with money too, but then the most of the projects are private, right? But in Web3, you have your projects to be open source, public. Anybody can look into your code, and the tiniest of mistakes in your code can cost your protocol or your business billions of dollars, billions of loss. That was why I asked about, oh, are we aware of smart contract acts? So why I am laying this foundation is there's a mindset you have to have, right? One, you have to like always be updated. There's a lot of things changing. Solidity is like relatively new, right? So there are lots of updates coming up day by day, weeks by week, months, and like improvements being made. So you have to like know how, okay, what was working yesterday and what is different today. Do you understand? So in a nutshell, in essence, the whole ecosystem is like very, very broad and like consistently changing. You have to like keep up with a lot of things. And number two, while you're developing, right, you have to like put into consideration, oh, um, what I'm building, is it secure? How can I safeguard against this? And you know, talking from a concept of transaction gas, we know that you pay gas fees, right? When you're running, when you want to like execute a particular function on a smart contract, right? Are we following, please?
Yes, I am.
Yes.
Yeah.
So
Yes, yes, I
there,
am.
so, the way you write complex code in JavaScript, where you use your for loop for each and the likes, is not available in Solidity. Everything you want to do, either you want to like loop in through an array, is done manually using your for loops. There are no methods are available for you, although there are libraries you can use. But the core essence is that you when you know this concept, you're able to like optimize your smart contract and save gas. And as we go like further, you understand this concept and why these things are in place and why you are to do why certain things are done and why certain things are not like done like that. Please give me a minute. So as I was saying, so enough of the story. I just like want to like give you an insight about of what you're coming into. So the complex code you write in your previous like in the previous what's the word now, like the complex JavaScript you write, you have to like write a simplified code here. So what we'll be doing today is I didn't come with any resource because I wasn't sure I was going to be able to like make the class. So, but I think from the curriculum, we are to like treat the basic concept of solidity, functions. Yeah. So it's good that we've been introduced to Visual Studio Code, ADAT. There are a lot of other tools like that. The same, all these tools, they share similarity. You know, the way you have your, I don't know, the way you have your Android, like your iPhones, or you have 1, 2, 3 to like 14. You know that there are different features that these phones have, similar to tools like that. At the early stage of development, we had Truffle, and Truffle. With Truffle, you can write your smart contract, deploy your smart contract, write script, and do a lot of other things like that. But with as time went by, we needed a way to like make these processes easier. Then ADAT came about. So with ADAT, you can do minute forking. What do I mean by minute forking? Like, you know, when you like write your smart contract, it is because your smart contract will be owing money, right? It is advisable, like it's a must you test your smart contract first, right? So, and in order for you to test, you have to like simulate the network environment. So let's say after testing in a network environment, you want to see how your smart contract is going to like behave in the mainnet. You can get a snapshot of the mainnet, which is the Ethereum or whichever blockchain you're building on. And it's so in simple term, um, ADAT is robust compared to Truffle. So it still does the same thing as Truffle, but then it does it in a more easier and let's say faster manner. And the newest tool that just came out now is Foundry. Foundry does the same thing, but in Truffle and ADAT, we write our deployment scripts, our testing JavaScript, or best you use TypeScript, right? But now to the lowest level, you can write your test, your script in Solidity, right? So that's what that's one of the things Foundry gives you. So, and Foundry is like amazingly fast. So I don't think that is in our curriculum, but I could always like share resources to how to learn how Foundry works. So for this class, we'll not be making use of Visual Studio Code, we'll not be making use of ADAT because basically we don't know anything yet, right? But with time, we get to like move to those development tools. So the tooling we'll be using now is basically Remix. We all know Remix, right? I'll cast my screen now. Do we all know Remix?
Yeah, we do.
Yes.
Yeah, you have an idea.
Can you all see my screen, please?
Yes, I can.
Yes, I can.
Yes, I can.
So Remix is an online IDE, right? Where it enables you to like write smart contracts. You can also like write tests, you can write scripts, but then it's dependent on you having network like internet access. You can also what do we call it? You can also like simulate your smart contract via injected Web3, like testing via your MetaMask and the likes. So I don't know if you've explored this, but this is just how the environment is. This is where your compiler versions are. You can choose any version you want. So if you want to like simulate a with injected Web3 with your MetaMask, you choose this option, and then you have to authenticate that you want your MetaMask to be used for deployment. So I know that you're already familiar with this, so I'll just like go straight to the talk of the day. So, okay, variables, data types, coming. Probably in our next class, I would come with so like we all know that, yeah, for every what do you call it, for every programming language, yeah, you have the fundamentals that makes that are like building blocks, right? You have data types, right? So in JavaScript that we are all familiar with, you know that you have the data type number, you have big number, you have strings, you have arrays and objects and the likes. Similar for Solidity, you have what do we call it? You have the data type as let me make as Boolean strings. You have mappings, you have arrays, you have string mapping, structs, you have integers, which give you signed, so these are the data types you have in Solidity, but then the data types can be divided into two. Remember, in JavaScript, you don't have to like deal with anything like memory or the likes, but one thing you have to like know about Solidity is statically typed. What do I mean by statically typed? You have to like for every variable you declare, or for every variable you declare, right, you have to specify the type. Say I'm coming. So pragma. So what's the importance of like the essence of line one? What am I trying to like do? Can anybody answer like the question? Sorry, line two. Is you're making it seem as if I'm the only one in class, or
No, well, I'm following
Well,
you.
you know, I can hear you.
we've been introduced to what smart contract are, like you said. What does this line do? Does like this line, no, line two, what does it do?
It
I don't have an idea because she didn't explain the details. She just walked us through how to use the rhythmic.
so
Uh,
line
okay.
two, can I
Sorry, it's
answer?
like a
Yeah,
version.
go on, please.
Okay, line two, I think it specifies the Solidity version that we're using for the projects.
Yeah. Interesting. Yeah, you're right. So for
Can you hear me?
okay. Yeah, I can hear you. I can hear you. Can you hear me?
Yeah, I can.
Yes, I can.
Yeah, so on line one that says XPDS license identifier, you're basically just specifying like the license for your smart contract. It is not really mandatory, but then if you're writing a production code, you have to like specify. Take for instance, Uniswap V3 now specifies that I think BSUL or something like that. So that identifier they specified is like a copyright to their code that you can. So for the BSUL stuff they specified on their smart contracts, that means you can't use their like you can use their smart contract, right? Like I think for the next 10 years, right? But then the previous smart contract they've written, I think it's either MIT or GLPU. So MIT, GLPU, they are open source, right? So you're specifying an identifier for your smart contract. Let me quickly check for let me finish. Is at any point in time, if you are confused, please always like call my attention, right?
Okay, no problem.
All right. Awesome. Oh, they didn't specify. Okay, just continue. So okay, you have your identifier, then you on line 2 you're specifying your smart contract, your compiler version. Which compiler version are you using? So you want this code to like use compiler version between from 0.8.2 to higher version, like that is to the highest version. And if I should remove this caret sign, I'm just saying that okay, use Solidity version of 0.8.2 only. You understand? And I can choose to like specify that okay, use Solidity version of let's say that ranges between 0.40, something like this, greater than equals to 6. Let's try 6. Like you can like specify different Solidity compiler to you want to like use for your project based on whatever you want to do. Different compiler have different versions. So I think 0.6 doesn't have the overflow and underflow check, but the newest version that are out now, they automatically check either underflow or overflow for you. We will still like get that concept. So as I was saying, data type in Solidity. Okay, sorry, I wanted to like give you like an overview of. So you specified your compiler version, then let's say so this is how you say we want to have contract hello. So at the lowest level, this is what your contract looks like. And everything else you want to write goes into this space. You can also have a new contract here, right? Let's say contract high. So Solidity supports inheritance. You can inherit contracts. So if you know the concept of object-oriented programming, right? So everything peculiar to object-oriented programming, such as polymorphism, encapsulation, inheritance. I think there's one left. There's one concept left. Is applicable to Solidity. So going back to our data types, right? So we have what we call value types, and we have reference types. So we're going to like quickly go through a quick article to like explain what value types are and what reference types are. I am sorry for not coming up with the resource once again. So permit me to like navigate us around like different resources, please. So the ultimate guide to data types in Solidity. So Solidity is a high-level object-oriented programming language that is used to write smart contract and build tabs. Like I said, it supports OOP, it's object-oriented, right? It supports inheritance, use of libraries, and sophisticated user-defined types. We'll see what they mean by sophisticated user-defined types, right? So Solidity is statically typed. What do we mean by statically typed? You always have to like specify the data type of what you're using. How many of us write TypeScript here?
I do.
All right. You know, let's say you have function, let's say function sum, right? You're passing into parameters where you have to sum A and B, right? For TypeScript projects, it will always enforce you to like like specify the data type of the variables you're passing into that functions, right?
Yes.
Yeah. So similar to Solidity, you have to explicitly state the data type of the variable you're declaring or whatever you're using. So it says the difference between data type in Solidity and other programming languages are like subtle, but significant enough that many developers find this topic sort of confusing. Like other programming languages, Solidity classifies data into different types, right? But Solidity is somewhat unique in that it has several elementary types that can be combined to form complex types. This article is designed to be a comprehensive guide to Solidity data types, right? So like we've established, you have data types, but your data types are divided into two. You have the my mom calling. Wait. So you have the value types, and then you have the reference type. So let's just dive right into it. So the example of Solidity value types we have this integers, we have boolean, we have addresses, we have enums. So let me just like bring them here. So let's start with value types first. Please, are we following? Any conclusion so far? Any questions so far?
None for now.
No.
Take notes.
None for now.
Yeah, you have the recording after. All right. So yep. Check. Okay. So you have signed integers and unsigned integers. Use your signed integers and unsigned integers basically represent numbers, but they differ one way or the other. And I mean, the reference type, you have fixed array, you have dynamic array, you have bytes array, you have strings, you have struct, and then you have mappings, right? So what are value types now? The value type stores the data directly in memory, in the memory it owns. Variable of this type are duplicates whenever they appear in function, or are duplicated whenever they appear in functions or assignments. A value type will maintain an independent copy of any duplicated variable. Therefore, a change in the value of a duplicated variable will not affect its original variable. There are several value types in Solidity. We have signed integers, unsigned integers, Boolean, and then address, enums, and bytes. So what is a signed integer? A signed integer is declared with the int keyword. So this is how you like define a signed integer. Say I have int 56. Right. So where we declare there's something in Solidity too when it comes to dealing with numbers. So we have so you can see int 256. Come, let me spin up something. Sure. So like I said earlier, like when you're like writing your code, you have to like look out for optimization and things like that. So this uint 56 basically it has the amount of data it can take, right? So for signed integers, basically signed integers can take both positive integers and negative integers. If you go back to this material, it says a signed integer declared with int keyword is a value data type that can be used to store both positive and negative values in smart contract, right? Int is an abbreviation of int 256, which has a range of -2 exponential 2 raised to power 55 to 2 exponential to 55 minus 1. This value type makes up 32 bytes by default. Thus, but we can make it smaller by specifying the value of bits in steps of 8. So I said this unit 256, right? It represents like the highest number, like it has the maximum number it can take, right? So sorry, I'm trying to like process something. Should I talk about this? Okay, so let me quickly like bring this into light. So when you're dealing with okay, you remember us talking about EVMs, right? That the EVM is it has a word storage of 256 bits, right? Do we remember that concept?
Yes.
256 bits, which equivalent to 32 bytes, right?
Yes.
Is it that we don't understand, or why is no one responding?
Yes, we are following you.
See, it's not enough that you say you are following me. I need to like understand that, yeah, you understand what I'm saying. Because everything I talk about, everything would like talk on is like a build up to an advanced concept. I don't want a situation whereby you will not understand the concept, right? And then we have to like fall back to it because there's limited time. That's why I'm like trying as much as possible to ensure that everyone is like following. Okay.
Okay, someone like me, I'm just knowing all of this for the first time, so I'm absorbing all what you're saying. So when I have questions, I will ask.
All right. So for this unit 256 now, it has like the maximum number amount of number it can take, and in storage slot, it's equivalent to like 2 bytes. So like you already said here that you have these ints, right? That you have this number in steps of 8. So that means you can have where is the remix? So you can have int 8, int 16, I think int 24, yeah, int 32, up to 256. And looking at this now, let me use okay. So signed integers can contain both positive and negative integers. Similar for unsigned integers too. So unsigned integers are represented as uint, right? They also follow the order of like sequence of steps in 8 from 8 up to uint 256, right? 2. So let's say I want to like know the maximum number that this uint 256 can contain, right? I just do type dot max. How do I should remember? I think I'm coming. Please, uint 256. Okay, yeah. So to like know the maximum number uint 256 can contain, this is it, right? And imagine you're storing, let's say, the variable 2 inside this kind of stuff, right? It's like somehow too large. So like that, you can just like start from the lowest. Let's say uint 8. So let's see the max that a uint 8 can take. Uint 8. 28 takes 255. And how do you arrive at that 255? That's 2 exponential 8 minus 1. So you have 256 bits minus 1. So that gives you 255. So that means this can stop between the range of 0 to 256 amount of numbers.
Sorry, I'm
But
lost. So
you don't need to be lost. You know, okay, we already said an example of value type is integers, right?
yes,
Right?
I understand in
You
simplicity.
understand to
But
that
yes,
level. And we established
yes,
that integers are divided into two. You have the unsigned integers and the signed integers, right? Did you understand that
yes,
part?
yes, of
All right.
course.
Yes.
And
Yes,
your signed integers, which is like denoted with int keyword, right? You can start from int 8 to int 256, right? And what makes your signed integers, please can you mute your mic? Someone mic is not muted. Thank you. So how does int differ from uint? Int takes both positive and negative integers, right? Coming down to uint now, uint takes only like signed unsigned integer takes only positive integers, right? So I'm trying to like show us that okay, you can start your uint in the order of 8, 16, in steps of 8, depending on the amount of number or like the size of the number you're dealing with, right? So I'm just like trying to like explain this. So that was why I showed us like the maximum amount of number a unit 256 can contain compared to a unit 258. So you know that if you're trying to like store, okay, like we can see that a unit 8 can take highest 255, right? Right?
yes,
So I've assigned 3 to it. The compiler is not complaining. It's not complaining. I assigned 255. The compiler is not complaining. Let's see if I do 257. There's an error. It says it's not implicitly convertible to expected type unit 8. Literal is too large to fit in unit 8. Do you get what I'm trying to explain now?
Yeah, I do.
Are you sure?
Yes.
Please does
I
do
did,
you
I did. I think, okay. So are you trying to say that once it exceeds 255, the error message will show up?
yeah, that it's going to throw you this error. Basically, in a nutshell, what I'm trying to say is for each unsigned integer you utilize, right, there is an amount of data it can contain. You understand? So for a unit 8 now, right, you have 2 raised to power 8 minus 1, which is going to like give you 255. So this can contain more than this can contain a unit 8 can contain more than 255 as a number. So if you try to like increase this number by, let's say, by 2 or by 1, it's going to like the compiler will throw you an error that oh, this is too large. Let's say I up this by 8, I take it to unit 16, it won't throw me an error because obviously the highest number you can say in a unit 25 and in a unit 16 is this, which is 65,535. You understand? So when we get to the concept of gas optimization, we are going to like learn about this concept. I'm just like giving us an overview. So we established that we have integers, right? And our integers are divided into signed and unsigned integers. And moving on to the next one, we know we have booleans, right? Booleans which we have either true or false.
Please, I have a question.
Okay.
Can you hear me?
Yeah, I can hear you. Go ahead with your question, please.
Okay, so where you have int 32 norm and where you have you in 16 norm 2, that norm and norm 2, is it like the variable name?
Yeah, oh, sorry, I forgot that. I forgot to explain that. So this is you're specifying the type here, right? And this is the variable name, the identifier. Do you get?
Okay, yeah.
So you can now assign, oh, I want this to be so number like that. We get.
Okay. Okay, thank you.
So if I so another concept we don't have we don't have let const or all those jargons in JavaScript. We don't have it here. So if you want to like declare a variable, right, you just like specify the data type and then the identifier, that is the container or the variable name, right? Like we've done on line 26 and 27. Can I proceed to another thing, please?
Yes, you
Yes,
can.
you can.
So moving on. So unsigned integers declared with uint keyword is a value data type that must be non-negative, right? That is, its value is greater than or equals to 0. Uint is an abbreviation for uint 256. So if you say uint, right? Let's say you say uint, you're implicitly saying uint 256, but it is good to like be explicit. Is not good to like have your compiler doing guesswork for you, right? You have to be like be explicit. If you're declaring a uint 8, let it be uint 8. If you're declaring a uint 256, always be like be explicit with whatever you're um declaring, because your compiler does not read mind. You're giving it, you're supplying it a piece of code, and that is what is going to execute for you. So we've seen unsigned integers. So moving on to Boolean. Boolean types, everyone is familiar with Booleans, right? And Booleans are either true or false. The data type takes up 1 byte. So it's important to like know the byte size each data type is taking in memory. You understand? Because you have to like be explicit about the memory allocation you're doing in Solidity. Are you specifying a memory location? Are you specifying a storage location? If you're writing to storage, right, it's you're paying gas, right? Writing to storage is actually to code storage. What I mean by code storage is you're writing to a particular storage slot for the first time. It is it takes more gas to do the writing, right? Compared to when you're writing to an alt storage, let's say somewhere that has been written to before. So your uint 256 now, equivalent 32 bytes, right? Where your uint 8 equivalent uint 8 is 1 byte. So you can see like there's a significant difference, right? So the higher you go, let's say you have your uint 16, your uint 16 now will be 2 bytes, right? So you have to like be conscious of this. Like we already established that how the Ethereum virtual machine, a word in one storage slot equivalent 32 bytes, right? Yeah, 32 bytes, which equivalent 256 bits. I know make sense now, but just like note these things. It will like everything will like connect and click at once. So it says your boolean, be it the true or be it the false, as takes 1 byte of storage. You get that? So Solidity supports all standard boolean operators such as inequality, equality, logical negation, logical conjunction, and logical disconjunction. It is essential to understand that you cannot translate the Boolean data type into integer in Solidity like you would do in other programming languages. Also, in Solidity, any assignment to Boolean variable creates a new copy of the variable. So basically, yeah. So let's say I want to like declare a
Please, can
boolean
you
now.
drop the hello
Yeah, I will. I will drop the resource
the
definitely.
link to this? Yes, thank you.
So if I want to have a boolean variable, let's say I want to have a variable status. Remember, you can't use the let or the const that you use um in JavaScript. Let's say I'm initializing this one to be false now. Throw an error to say type boolean is implicitly convertible to expected unit 8. What it's saying basically is you have to specify the type. Is it a boolean you're trying to like talk about? Is it signed integers, is it unsigned integers, whatever? So what we are trying to do here is like have boolean here. So you can see that yeah, you can see that it doesn't throw any error because you've explicitly stated that okay, I want this to be a boolean. And another thing for Solidity, there's always a default type, a default value for these types. So for Boolean, default value of Boolean is false, and for signed and unsigned integers, the default value is 0. For which other one? Yeah, basically that's it. So another um value type is your address. We all know what address is, right?
Yes.
Yes.
Yes,
All right.
like our Ethereum address, right?
Yeah, we do.
Yeah, exactly. Your Ethereum address or your contract address. Either would. So an address value type is essentially designed to hold up to 20 bytes or 166 bits. Emphasis on the memory, the size that this value can, that these um, value types can hold, right? It's kind of like them. So address is a 20 bytes, right, which equivalent to 256. And how do we get that 256? We know that 8 bits equivalent to 1 byte, right? And 20 bytes like that, 20 bytes, that will be 20 times 8, which will give you like 160. That's how we got this 160 bits. You understand? So which is the size of an Ethereum address. So Solidity offer 2 types of address. So so we've done
I
signed
have a
integers.
question. I have a question.
What was your question? Go on.
Okay, so now does it mean that we think when we are writing our code, we have to put into consideration each of these sizes to determine the storage space we are going to be using?
Yes, exactly. So, but where that comes in is when you're like trying to like optimize your code, and I wouldn't want to like touch about that because for now it's a little bit kind of advanced for what we want to do. Not like advanced. It's something you're still going to like later learn in the class. But say, take for instance now, let me just give you an instance. So we've not got into this. Um, Should I do that or not do that? Should I do it or not do it? Should I do it or not do it? We'll get to it. Don't worry. Don't let me carry us to where we don't know. So you guys not be screaming, help me, help me, help me. So I'll get back to your question, right? I'll tell you, like I already said, the virtual machine, like the storage layout, right? It has a word size of 256 bits, which equivalent 32 bytes, right? So when we get to that, please, I'll let you like know when and when not you like need those concepts. Please remind me. We'll soon get to it now. So it says another value type we have now is the address, right? I am coming. So let's classify this one as integers. method. We have boolean. Which do you have address? So for our address, we have address. We have address, and we have address payable. Yeah. So what differentiates these two? They are still they both have the same properties, like they are both address, right? They have their size is 20 bytes, which equivalent 160 bits. But the difference between them is between address and address payable is the difference is that address payable can send and transfer ether, right? We can use an address to acquire the balance using address.balance, and also we can use it to like transfer. So the basic difference is that when you specify um, address, right? When you use address, if you want that address to receive ether, you have to like you have to especially state that this you want this address to be payable. That's where this address payable comes in. You understand? So you're basically saying, okay, this address can receive ether. We'll still see like code example when we get to that. So we can use address to acquire balance using the dot balance method, and to transfer a balance using the dot transfer method. So if you want to specify an address now, let's say I want to declare an address, right? I say address, let's say underscore user, right? So this is, you specify the data type and then the identifier, which is your variable, which you want to like use for.
Sorry, why the underscore?
It's just my own convention. You can use user,
Okay.
whatever one works for you. Do you get?
Yeah.
So we have enums. Enums are enumerations. Value types in Solidity consists of user-defined data type. This data type is used specifically for constant values. So when you have instances where you are, when you want to like have, let me use the word like choices, right? Let's say constant values, right? That's where your enums kind of comes in. Enums, another value type. And how do you specify enum? You specify enum as the enum, let's say status, right? Okay. Yeah. So this is how you like specify enum, but you can see that it's saying, oh, what's the error? It's saying enums with no member is not allowed. So you have to like specify a member for it. So let's say I want to, like in my smart contract, I have I'm writing a smart contract that says, okay, I'm just keeping track of, let's say, gender, right? And how do I keep track of those like gender? I can specify an enum and say, okay, enum gender. I can have male, right? I can have yeah. Okay. This is how you specify an enum. So whenever you want to like utilize it, it's just like preference, okay, let's say gender dot maybe male or something like that, whatever you want to do. So we've seen integers where we have the signed and unsigned integers. We've seen address, we've seen enums, we've seen each other one boolean. So I think that is all on. Okay, bytes. In Solidity, byte refers to unit 8 bit signed integers. Everything in memory is stored in bits with binary zeros and ones. So what we're trying to say is that like your high level language, your high level code that you've written is compiled like down to the simplest form, which is like the bits and which is like the bits, because that is what the computer understands. That's like the machine language the computer understands. So all these your complex code such as I don't know, such as this, it doesn't understand that. So it has to like convert it like down to like to the bits and bytes level, right? So if you have variables or values in its lowest form, let's say you want to like represent values in terms of bytes or in terms of bits, you can easily use this byte data type, right? And it says the bytes value in type in Solidity is dynamically sized byte array. It is provided for storing information in binary format. So if you have any manipulation or any data storage you want to like do in binary format, you can easily like specify the byte data type, right? So to reflect this, Solidity provide a wide range from byte 1 to byte 32. So the data type byte 1 represents 1 byte, and then the data type byte 32 represents byte 32 represent 32 bytes. So basically what I'm saying is where's it also? Are we following, please?
Yes,
Yes.
I am.
Yeah.
Any questions so far?
None so far.
I have problem finding variable names. Let me just call this one A. So this is byte 1 now, right? It represents 1 byte. So you can have a sequence of byte 1, byte 2, byte 3, byte 4, up to byte 32. And byte 1 will only take equivalent, I think, OX, I think O1. So remember, since you've specified byte 1, it can only take the size of like a byte 1 data. If I try to like make this bigger, let's say 5 6, it's going to throw error. It's going to say it's not implicitly converted to expected byte 1. That is like it's too, what I'm trying to store is like too large for it. So it says states it there. So the data type byte 1 represents 1 byte, while byte 32 represents 32 bytes. 0x00 is a default value for bytes. So remember we said something about um, data types in Solidity having like their default value, like you have your integers um, as zeros, you have the boolean as false, you have your address as OX0000. So let me just do something. Okay, I don't need to do that stuff. So that is that about bytes. So when we like this is just like introducing us to the concept of the value types. Now we've get with the value types now. Now we are going to like the reference types. So why do we have value types? Why do we have reference type? In the in JavaScript that we are familiar with, we don't do things like, or we don't handle memory ourselves. JavaScript does that for us, right, out of the box, right? But in Solidity, when you're writing your smart contracts, you have something called storage layout, which can be like memory location, which can be either storage as well as memory. So this storage now, you're writing to like you're saving that variable, right? You're saving it to the state of your smart contract. But if you're specifying memory, whatever you do in memory is like temporary. You understand? So during that function execution, once that function execution is done, it sheds off those arbitrary data. But if you're writing to storage, you're writing directly to storage. So whatever you're specifying is going to like save. Do you understand? So that's the difference. So you have to like undo these things yourself. You have to like know when you want to like write to storage, right? And when not to write to storage. And like it's dependent, it's customizable. There are no like strict rules like that. You just have to like know when you want to like do certain things and when you don't want to like do certain things. So where this memory concept comes into place, let's say you have certain number, let's say you want to like run a for loop now. You want to like you have an array stored in your storage, in your contract storage, right? It's not advisable to like access that value in storage and then iterate on it in storage. It's going to consume gas. And at the end of the day, might like equally fail, right? What you can do is like copy this data from storage, copy it to your memory. When you have it in memory, do the calculation you want to do the iteration you want to do, the manipulation you want to do, right? And once it is done, the results of what you get, you store it back to storage to replace whatever data you have previously. Do you get? So we are still going to like talk more on storage location where we have like the memories, storage and core data and the likes. So reference type. So Solidity reference type differ from value type in that they do not store value directly on their own, right? So reference type do not store value directly on their own. Like what we said here that okay, let Boolean status be false. This false is in the status container. It serves as like as a container for it, right? And whenever it wants to like be where this status wants to like be reused, it is copied, right? And this value is not going to like change unless like you reassign it a new value. But reference type, they point to a place in memory. Do you understand? So that's why they seem somehow complex and different, right? Say, for instance, your array. If you specify an array now, let's say you specify an array will probably um, reference the address in memory. Let's say the memory location in your CPU or whatever you have is like let's say 0x 01 or something, right? You're not storing that value in that variable exactly, but you're making a reference like to a place in memory that okay, like store this also number for me or also data for me in a particular place in memory. And when you want to like retrieve it, you retrieve such number from that particular point in from the address on your computer or whatever. So reference data type must be handled consciously since they deal with storage location. Remember the storage location we talked about storage and memory. Data location affects the amount of gas used in a transaction and therefore can negatively impact smart contract development performance, right? When using reference type, reference variable points a user to a location of value storage and can take up more than 32 bytes of memory in size. Two separate variables can refer to the exact location, and any change in one variable can affect the other. Several variables that point to the same address can be used to effect a change in a reference data type. So the example of reference type that we have the fixed size array, we have dynamic size array, we have array member, we have bytes array, strings array, struct, and mappings. So arrays. So the arrays in Solidity are quite different from. Wait. Any questions so far?
No, not from me.
I hope there are no confusion. Do we understand what we've been talking about?
Yes, I do.
Any question on value type before we move to reference type?
Did I have a question?
No
Yeah, go ahead with the
question.
question.
Okay. Sorry, can you hear me?
Yeah, you can.
Okay, so I just wanted to ask about the enum value type. So I think you mentioned something about it being constant in a way. So is it like kind of similar to, like, let's say in JavaScript when you're declaring a variable with the constant keyword, showing that, let's say, it's going to be constant throughout, that is not going to change. So is that like what we are having in that enum?
Not exactly, because the keyword constant also is applicable to solidity, right? Say you have what we mean by just constant, what we mean by constant is, okay, you already know the value is going to, like, you know what those values are, right? Like, it's not going to like change. Like the example I stated, um gender, right? I used either male or female. Sorry, gender is like far too much because there's a lot of complicated stuff about it. Let's use let's use status, for example. A status can either be either success, can either be false, or can either be pending, right? So what approach is like best to like use to like represent this? So you use your enum. So let's just check solid documentation to like get explicit understanding of what enums are. So one other reason why we'll be using the documentation a lot and other resources are, I understand that like the way I understand things differs from the way another person is going to understand. So it's rather better we like go through the source of all truths together, which is the documentation, right? Then you can like pick your own um your own understanding of the concept from whichever approach you want to like use. So the documentation says structs are custom defined type that can group several variables, right? So you can use it like to group several variables. So no, shit, no, I mean enums. Sorry, I searched for the wrong. Okay, not wait a minute, please. Struct is different. Okay, enum type. Yeah, this is enums. So enums can be used to create custom type with finite. Can you see the screen, please? This
Yes, I can.
oh, I highlighted. So enums can be used to create custom type with finite set of constant values. So you know that those values are not going to change, like they are constant values, right? So you specify them as enums. Take for instance, you have let's say you have a shipping no. Okay, let's say you have a shipping company now, and whenever you dispatch goods out, the status can either be successful, it can either be pending. We know we all make use of Jumia now. I don't know. So there you always like get the status of how like the status of your item, has it been shipped out for delivery? Is it still pending? Are you getting it from the supplier or things like that? So it's just like define custom types with a finite set of constant values, right? And the concept of constants in Solidity, um, concept of constant is applicable to Solidity such that let's say you're performing a calculation, right? You're not expecting dynamic data, right? So you can easily like specify that variable or that number or that value to be a constant. So that way it's not going to like take any available space in memory. In storage rather, it's not going to like be stored. It will just be added to like the contract runtime code, right? Like it will be inserted everywhere you specify that variable to be used. We are still going to like see more on that. Sorry, did I answer your question? Did that answer your question, please?
Yes, thank you.
Okay, not too much. Um, uh, all right. Reference type. What? My networks. Sorry, give me minutes, please. All right. Sorry, I had to answer a call. So arrays in Solidity are quite different from the array we have in programming in other in JavaScript. So similar to Java, similar to C++, similar to Rust and Golang, Solidity shares some similarity with these programming languages. But when it comes to JavaScript, in your JavaScript, right, you have your, like I already said, we don't have the for each, for in, all those sweet syntactic sugar like methods that makes life easier. In Solidity, life is hard, right? So moving on, in for arrays. Why they scare us now? So we in arrays now we have fixed size array and we have dynamic sized array. What do we mean by fixed size array? So fixed size array basically specifying that, oh, this array that I'm declaring, let's say I have okay, so you just don't say array something, you just don't say array whatever. So if you want let's say you want you're dealing with numbers, or you're dealing with whatever data type you're dealing with. Let's use number as an example. Let's say I want an array of number, right? Let's say I want a unit 8 array of numbers, right? I can specify, this is how I specify okay, numbers. So yeah, what we have here is a dynamic size array. And on dynamic size array, we have properties such as your push. Yes, you have your pop. You have dot length as well. So you can push items into this array. So that means this dynamic array means you can take like arbitrary length of data, like as much data as you want. But let's say you want to like specify a fixed size array. How do you specify a fixed size array? This is how you specify a fixed size array. Basically, let's say unit 8. Remember, you're not restricted to unit 8. It's dependent on what you want to do. It can go as far as 256. Remember, in steps of 8, right? So I want this to be unit 8 and 8 now. So this means that expected. This means that this can contain just 8 items. And another important key point to note, you can't have mixed item in your array. You can only have items of the same data type. The way we combine strings, numbers with objects in arrays in JavaScript is not possible here. You have to like state an array of number, it should be pure numbers. If you're stating arrays of strings, it should be pure strings. If you're stating arrays of structs, it should be pure structs. You can't mismatch data types in arrays. And for fixed type, you don't have these properties available for you. These properties are available just to the dynamic sized array. So that's just basically it. I'm just like trying to like establish this foundation before you like dive into coding and know the possibilities and what is possible and what is not possible. Do you understand? Jesus. So fixed size array have predefined size when they are declared. So like we said, they have predefined size. So this means this can only like take 6 items. In Solidity, we cannot use the new keyword with a fixed size array. Instead, the array data variable must be initialized inline. So we're still going to like get to this. So when you're like initializing the value of fixed size array, you use you initialize them inline. But when you're initializing you use you initialize them inline, right? Let's say we have I think I'll have to like take us to another concept, but let's do this first. So if you want to initialize this now, you just have expected number equals to let's say 2. Whatever number you want it to be. So this might like receive I don't know, a parameter or something. So the function I just wrote brings us to another concept. You can see this public. Let me just note this on function visibility. Can be external public. I know most of us are eager to start coding, but if you don't know all these concepts, you just write efficient code. I mean, I think I have a resource function. I have a material that explains it like very, very well. Yeah, so when we get to functions, we like talk about this. Let me just open it down. So this is a dynamic size array. Dynamic size array do not have predefined size. They are declared. When they are declared, instead, their size is determined at runtime. That is the number of items you like push into them. You can initialize a dynamic array either inline or by using the new keyword. We are still going to like see that. So array members have the following properties. They have length, push, pop, and okay. So bytes array are similar to the bytes we like spoke about previously, but then they act like arrays, right? They have they have members, right? A byte array is a dynamic array that can hold any number of bytes. These differ from bytes value type we discussed earlier, right? They differ somehow. They can take byte 32 for each variable. A byte array holds all the bytes together tightly. The bytes array can be used in the following way, right? To declare a state element with initial length size, divide into code lines that are similar to the array previously discussed, okay, assign values directly and have values pushed into it, provide a read or write length property. So strings, the way strings are somehow funny in Solidity, in the sense that we can't really like classify them as either value type, but they are reference type because it's dependent on like the length of the strings you're trying to like store. You understand? So if you have right, so strings are dynamic like byte array, but they have unique constraints. Like I said, for example, string do not have an index. So in JavaScript that we can get like index of a particular string, you can't do that here. It lacks array members such as length, push, pop. right? If 3 is needed to perform any of this function, variable string can become okay. So if you need to like perform any of these functionalities on string, like let's say you want to like manipulate string, you can easily use your byte array. That is, you convert your string to array, and then once you've done your manipulation, you convert those bytes back to string. Basically, the way you do that is like you type cast. So now we've seen reference type, you've seen value type, right? And the ones we have now is we have the struct, which is a reference type. Struct reference type in Solidity refers to a new or custom data type. You can use the struct keyword to define a structure. So we can see that Solidity has given us variable such as data types such as Boolean, strings, address, and things like that. But if we interact with DeFi protocol or any blockchain protocol, you know that sometimes you have to like fill some details, right? Where you like passing number, passing your address, and things like that. How do we keep track of like customs type? Like how are we able to like create more extend our data type? So the way we can like do that Solidity gives us is VS struct. So VS struct enables us to like create custom types, right? You have let's say struct um I don't know why do I always have issues with variable names? Let's say struct cat. Yeah. So what should our cart contain? We can have a unit 256 number terms of items. We can have say an have address owner of cart. And can we have one more? Can we have one more? Can we have? We already have the address. So you can choose to like keep track of the address or name, whatever data you want to do is like customizable. Let's say I want to like keep track of so like we can have these as many as possible. You can combine, okay, let's say I have Boolean status, right? So you can see that I'm combining, and let's say I have unit um unit 8 um, um seconds. Yeah, so you can see that we are combining both our value type and our reference type together, right? So what struct enables you to do is enables you to like create a custom type for whatever you want to do, right? So to get more practical, like more understanding, let's say I have struct students now. Let's say I want to keep track of students in a class, right? Obviously, I know that the student is going to have probably, I don't want to use the string, probably address. Let's use string actually. String name, address, location. No, 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 no. No. Say address, wallets. But this is actually not necessary. I remove this later on. And then we have what can we add? Let's say unit 56, we have age and what else? Let's just leave it at this as this. So we can see that we've created a data type of student, right? So I can easily use this as a data type now. Student, let's say student A. So I'm saying, oh shit, and B then. I'm saying, oh, this data type should contain like Sorry, what am I saying? Yeah, I'm using these students as a data type now. We are still going to see how we're going to like initialize this student data type. So this is struct, and coming down to okay, let's get the definition of struct. Says the struct reference type in Solidity refers to a new custom data type. You can use the struct keyword to define a structure, like we just did, right? Made up of multiple variables, which can be both value type and reference type. In most cases, struct is used to like represent a record, right? It is important to note that because structs must be finite in size, they cannot contain members of their type. This is not to say that structs cannot contain structs. If struct A can contain struct B, but struct A cannot contain struct A. What it's trying to say is that a struct cannot contain members of its own type, right? But you can have struct inside of a struct. Do you get? So moving down to mappings now. So in Solidity, mapping functions similarly to hash tables or dictionaries in programming languages. So in Python, I think hash tables are quite similar to objects in JavaScript. So just see your mappings as a key value pair, but the way it functions is somehow different from JavaScript, right? So mappings is the most frequently used reference type in Solidity. Mappings types are used to store data in forms of key value pairs, where the key can be any of the inbuilt data type except for reference type. So what we are saying basically in essence is, our struct we used to like define what do we call it? Define a custom type, right? So how do we, let's say we want to like keep track of we specify the data type students and the variables it contains, right? Let's say we want to like start initializing, keeping the records. We want to like have more like write into struct. I don't know how I'm going to like explain it, but let me just write the something. So remember, value mapping are key value pairs, right? Then you have the identifier here. Basically, what we are saying is, so what do you want? So your key here can only be value type. You can never have your keys to be reference type. You understand? And the value type we have, let's say we have the address, right? We have Boolean, whatever you want to do. So basically now, what I have now, I want to like have a mapping of, let's say I want to like use I have a mapping of, let's say the key is address and then the value is student. What is the identifier? Student. So basically, what I'm doing here is saying, okay, I want to keep track of each student, right? And what do I want to have like as my unique key identifier? I want my key identifier to be their addresses. So that is mapping. Mapping is somehow complex. There's still more concepts on mapping that we've not touched, like the way it handles storage and things like that, but we'll get to that later in the class. So because Solidity mapping provides an option for one data storage location, this data type is permitted for state elements. The mapping type is declared using the mapping keyword, right? Followed by the data type for both the key and then the values, which is separated by a what is this something called? Equals to, and by this sign, I've forgotten the name. Check it. So that's like everything on variables. So we've touched on variables, we've touched on data types. So we are still going to treat the concept of constant and immutables. So like we already explained constants. Constants are, let's say you're performing a calculation, right? And then you already know those numbers, right? You already know the value that that particular variable is going to hold. You can just like declare it as a constant, right? And Solidity would like automatically like handle it and not like add them to what do we call it? It won't add them, it will include them to the storage layout. So now to so how do we like use these things? How do we like combine them together and all these concepts we've spoken about, right? There's one thing I want to explain before we like go into that. So there are two ways we can I'm referencing JavaScript now. Is it named functions or something? Where you have your const, your function name, let's say sum, and then you have something like this, right? Your arrow functions tags. Some those functionalities are not allowed. So you stick to your conventional function approach where you have a function and then you have the function name. Let's say this is function sum, right? And what can go here are either the parameters you are going to accept for your functions, right? So the additional things you have to like include to your function. Normal JavaScript something, we are good to go. I can just pass in my parameters and stuff. But in terms of smart contracts, you're dealing with the writing to storage. So you have to like specify your function visibility. Do you want it to be public? Like the function visibility I stated there. Where is it? I think I had something. So I'm taking us to function visibility now. So let's quickly take this material. So function visibility is just basically saying when okay, let's read when a smart contract, when writing a smart contract, we can control who and what can call functions within that contract by specifying what is known as function visibility. These allow us to secure certain part of our smart contracts without having to write too much custom logic, right? And we have so before we get into different types of function visibility, it is helpful to understand what different categories of potential caller to a contract, to caller to a function are first. So what this is saying is, right, is that your smart contract that you write, right, who can call the smart contract? We have like remember the concept of okay. Remember we said you the Solidity supports inheritance, right? So a derived contract can call your contract. An external contract can call your contract. An external contract, that's what we mean by another contract. Derived contract is like a contract that inherits another contract. Let's say contract B inherits A. And then your contract can call some functions on your contract. So what this is saying is that there are three types of caller. The main contract itself, another contract derived, that is a contract that is inheriting from the main contract, and a third-party contract, which is an external contract. So the function visibility determines what subset of caller can legitimately execute the function. So let's see the four possible states a function can have is the private, internal, external, and yeah. So you can have private, internal, external, and public, right? So private, let's see what private does. A private function is one that can only be called by the main contract itself. Although it's not the default, it is generally good practice to keep your functions private unless a scope with more visibility is needed. So what we are saying is, remember, we said we have three categories of callers, right? You have your contract, you have derived contract, right? You have another contract. Please, are we following up? B, I've been speaking to myself.
I'm following.
I'm following you.
Are we confused?
I'm following. Not yet. I'm not.
Please, if you are
Not
confused,
confused.
okay, before we like delve deep into yes, into function visibility abilities, we understand reference type and value types, right?
Yes. Not really. Reference types.
Okay. All right. So let's go to function visibilities.
DM.
And I'll be dropping some additional resources and okay, let's just finish class first, shall can you please mute your mic, please? So a function visibility that is pegged as private, it means only your contract, that is your contract, can make a call to that function. Right? So it says a private function is one that can only be called by the main contract itself. That is the contract that has that function. Although it is not the default, it is generally good practice to keep your function private. That means if you have contract, let's say you have contract A now. Let me use this one example. You have contract A now, right? Say private. And this one, like so I am specifying the visibility as private here, right? Forget about these pure returns. I'm still going to like explain them. So if I have, let's say I have another function that says function call, let's say call it. That means in this contract now, it's only my contract that I can call this sum function, right? So that's what it's saying basically. And it can be called by any derived contract. It can be called by another contract, that is an external contract. So moving to the keyword internal now, an internal function can be called by the main contract itself and its derived contracts. As with private functions, it is generally good to like keep your functions internal wherever possible. But whenever you need, where you need internal functions, that maybe you have functions that are calculating or making a particular calculations, right? You're keeping the state just to your contract alone. Yeah, what's the question? What I mean by derived contract is a contract that is inheriting from another contract. So like I have contract A now, right? I have contract L. Let's say I have contract A. I can have contracts. Basically, I'm saying B should inherit from A. So that means all the function in A will be visible to B. That means whichever function I call in here, right, can be executed by in B. Whichever function I have here can be executed in this contract by the contract B. If I should mark it as internal, but if I should mark it as private, this function will only remain callable by this contract itself. Do you get that's what I mean by derived contract? So moving on, do you understand the person that asked that question? All right. So external, when we mark something as external, it means an external function can only be called from a third party. It cannot be called from the main contract itself or any derived contract. So what he's saying is, let me drop this resource because it's quite like very, very explanatory. So, and that's diagrams. So when you're going through it, you can just like, Elizabeth, are you on the call, please?
Yes, I am.
Yeah, could you please like paste these resources on the Web3 channel, like in your channel, so that others will have access to it?
Oh, okay, all right, no problem.
So what we mean by external now is that another contract can make a call to it, but can make a call to that your contract, but your main contract and derived contract cannot make a call to that function in your contract, right? And when we mark it as public, that means either your contract, either derived contract, either another contract can call that particular function. We get that's like the summary of everything. So lastly, I will explain the concept pure view. So we have private. This one can be private, it can be economy, it can be private, can be public, can be standard. When you have something called view, you have pure. So when you're writing your smart contract, you're doing two things basically. Either you're writing to storage or you're reading from storage. So when you're writing to storage, that means you're modifying stage, right? You're modifying the content in your contract storage, right? So if you're writing to storage, you don't have to like specify anything. You don't have to specify this either pure or view. But when you're reading from storage, you have to specify view. So this view does not modify state or reads. This pure does not modify state and does not what I mean by does not modify states. So you can see that, okay, let's say I have joint states right. So when you're passing your variables to, you have to like explicitly state your variable type. You get. So I'm writing to storage now. So I don't need to like specify whether it is V or pure because I'm writing to storage. Why are you complaining? Right. Oh, sorry. So remember what we talked about, right? I made a mistake here. I declared on line 23, I declared the unit 8, right? Online online 23, I declared the unit 8, but I'm trying to like use the data type unit 256. Remember, unit will implicitly mean unit 256. So it's throwing an error. It's throwing an error that type unit 256 is not implicitly convertible to expected type unit 8. So I have to like be explicit and state that I'm expecting a unit 8. So let's say I want to read the value I just stored now. So all I just have to like do is, let's say I call this on special specific as public. So now I'm reading from state, right? I'm not writing to state. I'm not um I'm not writing to state. I just want to like read the data from state, right? That's why I have to like specify view. And what am I expecting? I'm expecting that it's going to return a number to me. It's going to return a particular data to me, right? That's where these returns come in. Returns basically mean that, okay, I'm expecting this function to return the data back to me. And what is the data type of that data? Is a unit 8. You get, so I just do return. What is my variable name number? So this function, this pure function, it doesn't modify state. It doesn't do anything to state. You can use it to like do like pure calculations, pure manipulations. This function on line 35 to 36, it modifies state. It writes directly to state. That is why nothing was specified on it. But this function reads directly from state. Do we get? So let me just like execute this. This is just like a no. Don't use injected. So if I should like write, let's say I write 80, 90 rather. If I should read, you can see that it returns my 90 to me, right? So that is just basically it. That is it. And you can see that because I specified this as private, the sum as private is not showing at at this left hand side that, oh, there's a function called sum. It's because I specified it as private. I can only like make reference to it in my um my code. So I think we've dealt with reading from state variables, we've dealt with struct, enums, data type, and I think practically everything. So do you have any questions so far, please? Before this is just to like lay a foundation before you like start writing your codes, because what's the essence of writing code if you don't know these concepts? And what we'll be doing, like what will the next instructor will be doing basically is like introduce you to like how you like utilize this concept all together, how you like write, how you initialize struct, read from struct, return mapping, the return data from the struct, how you write to storage, and a lot of things like that basically before we like move into the more complex and more advanced concept of smart contract. So for today's class, any questions for me, any confusion, anything you want to like clarify that doesn't seem clear to you, please kindly talk, or we can call it a day.
For me, if I have questions later, can I reach out to you on Slack?
Yeah, no problem.
Okay, because right now in fact I've it's a whole lot going
A
on
whole
in
lot.
my head. So and
This is just the beginning. Oh. Never see something. Never see anything. You see shaky. Honestly,
ah
like I said,
Why they make us fear now?
this is not to scare you. I don't see. I won't sugarcoat anything, right? This is not to scare you. This is the space you are in. You have to like be up to date, know like know stuff your know what is going on in your ecosystem and try as much as possible to like um what's the word? In a nutshell, you shall walk. So I'm just like preparing our mind that this is not a simple man's work. So as some sort of encouragement, right? You have to like put in the work. Me myself, like I'm still like trying to like find my feet and um put in the work myself. Do you understand? So you are not alone. Whenever you have questions, whenever you're confused, right? You can always like reach out. And the beauty of it is you guys are in a community. You understand? You have each other, right? So what is expected of my like the Web3 ladies as they have their own expectation of you guys, but my own expectation that I'm projecting to you guys is once we do not limit yourself to what you're doing in class alone. We can't teach you everything. Do you get? Try and like watch tutorials outside of class, read the documentation, ask questions. Do you get? Those are the ways you learn. And you guys have yourselves, right? As person A is like trying to like understand one concept, I'm sure person B is diving into another concept, right? So when you bring those concepts together, right, it cements your understanding, it makes your learning faster. In a nutshell, the essence, the whole thing that makes Web3 easier, either you're doing the theoretical or the practical part, is the community. So if you have any question, put it on your Slack channel first. If someone answers your question, fine. If someone doesn't answer your question, then you can now reach out to me. You understand? So saying your eyes will see shege is not to like scare you. No, but that's the reality. You can't afford to like be lazy. That's it. So thank you very much. I guess this is the end of the class. See you. Good night.
Um,
thank you.